So now that we've discussed completeness constraints, we're going to talk about disjointness constraints. And again, these constraints also have to do with supertype subtypes. These are not completely foreign topics that are unrelated. So the disjointness constraint definition is a constraint that addresses whether an instance of a supertype may simultaneously be a member of two or more subtypes. Okay, and there are two disjoint constraint types. The completeness constraint had two rules, and the disjoint constraint also has two rules, a disjoint rule and an overlap rule. So the disjoint rule, which is one of the disjointness constraint options, the definition is a rule that specifies that an instance of a supertype may not simultaneously be a member of two or more subtypes, right? And so in other words, an instance of a supertype must be only one and only one subtype, okay? So as the example on the screen, you can see that there's a patient supertype, and then there are two subtypes, outpatient and resident patient, right? And you can see the lowercase d in this circle, and we know this circle now represents, supertypes and subtypes. The lowercase d means it's a disjoint rule, all right? So a patient can be either an outpatient or a resident patient, but not both at the same time. All right, so that's the disjoint rule. Essentially, as stated, an entity instance can only be one or the other. It cannot be both. A person cannot be both an outpatient and a resident patient simultaneously. So another example of the disjoint rule, continuing on the same mode, is, as said, an entity instance can only be of one type, right? And so here we have an example of the disjoint rule. We have a vehicle supertype. We have car, truck, and jet as subtypes. We have the lowercase d that indicates this is a disjoint rule. And again, what that means is that, with the lowercase d, and what that means is that every entity instance can only be one of the types, either a car or a truck or a jet or even a vehicle. And we'll talk a little bit more about, we've already kind of talked about partial specialization and complete specialization, or total specialization, sorry. But what this means, it can only be one of these four things. It cannot be more than one simultaneously, right? And we'll kind of come back to this, but what you can see here is that we have what's called a discriminator, and we'll be talking about that in about 3 or 4 slides. So the other option for disjointness constraint, we talked about disjoint rule. The alternative is the overlap rule. So the overlap rule definition is a rule that specifies that an instance of a supertype may simultaneously be a member of two or more subtypes. Okay, so here we have a part, and we have manufactured parts, and we have purchased parts, and we have the lowercase o that indicates that this is an overlap rule as opposed to the lowercase d for the disjoint rule. All right, and what we're saying here is a part may be both a manufactured part and a purchased part at the same time. But it must be one or the other due to total specialization, the double line. I don't want to complicate things at the moment. We're going to talk about the combination of disjointness and completeness in a couple of slides or in a couple minutes. For now, just realize that because of the overlap rule, because of the O, a part can be both a manufactured part and a purchased part simultaneously. So an example of the overlap rule. Again, we're using the same kind of example with a vehicle, car, truck, and electric vehicle. But here you can see, instead of using a motorcycle, now we have electric vehicle, right? And so what can we say? We can actually say that, the O represents that this is an overlap rule, right? And an entity instance can be multiple types. So for instance, you might have a Tesla, right? So it is an electric vehicle, but it is also a car, right? So the overlap rule means you can overlap subtypes. I can be both at the same time. And again, this is a discriminator. We'll be coming back to this in a couple slides. And so actually, let's move on to subtype discriminators. The subtype discriminator rule definition is an attribute of a supertype whose values determine the target subtype or subtypes. And there are two subtype discriminator types. Subtype discriminator types. There are disjoint subtypes, okay? And in disjoint subtypes, what you see is that you have the attribute of a supertype. In this case, this is the supertype, right? Employee, right? We know it's a disjoint subtype because there's a little d here. The discriminator is this attribute right here, the attribute whose values determine the target subtype or subtypes. So here's the attribute in the employee supertype, employee type. That's the attribute in question. This is the subtype discriminator, right? And what this will contain, this attribute, will contain either an H, S, or C corresponding to hourly, salaried, or consultant employee types, right? Now, because this is disjoint, we just studied this, because this is disjoint, an employee can only be one of these types. They can only be either an hourly employee or a salaried employee or a consultant. They cannot be more than one, right? And because of that, we're able to use a very simple subtype discriminator of a single character. Now, we don't have to use a single character. This is just arbitrary. We could say the subtype or the subtype discriminator could be hourly, salaried, consultant. It could be, hour, salar, consul. The point being, though, it can be a simple, single-valued value for this attribute. The other subtype discriminator is when you have overlapping subtypes. And again, this is something we just studied. So what is an overlapping subtype? It's where you have a little o in this circle, right? And what that means is that you can actually have an entity instance that is more than one of these subtypes. So in this case, a part can be both a manufactured part and a purchased part simultaneously. You can kind of ignore all these extra relationships, supplier and supplies off to the side. But because a part can be one or the other or both, we can't just use a simple attribute type like H, S, or C. So instead what we do is we create essentially a composite attribute. So here we have a simple attribute, right? Employee type. Here we have a composite attribute, right? Remember the parentheses. So what that means is there are multiple pieces to this attribute. And so each of the pieces for this attribute would be essentially a yes or no, right? So the part type here, right, can be manufactured, yes or no, also purchased, yes or no. So it can be a little bit confusing, but again, the idea really is that in a disjoint rule situation, a thing can only be one type. So you can use a very simple attribute value, H or hour or something, or S salaried, whatever it happens to be. But in an overlapping subtype, because a thing can be more than one thing, it can be a manufactured part, a purchased part, you have to essentially set it up so that you have a composite attribute that has a yes or no for each of those things. This may be sort of analogous to a truth table if you're familiar with truth tables. So here's an example, or another example. So we have the disjoint rule. We have a D, which means these are disjoint subtypes. A vehicle can only be a car or a truck or a jet. And so here we have the attribute in question. This is the subtype discriminator. So remember, with a subtype discriminator, you have one attribute, essentially, which dictates which of the subtypes an entity instance is. So for a Tesla Model 3, we would have the subtype discriminator value. The vehicle type value would be a C for car. For a Ford F-150, it would be a T for truck. For an F-16 Fighting Falcon, I actually had to look that up, it would be a J for jet. Nothing can be both a car and a jet. I don't think that exists, but at least according to this rule, because it's a little d, it's disjoint, nothing can be more than one of these things. All right, so an example of the overlapping subtype discriminator is when you have a little o in this circle, which means that you can have something that is more than one of these things. So again, we have the attribute vehicle type, but instead of being a simple vehicle type attribute, now it's a composite. Car, question mark, truck, question mark, electric vehicle, question mark. These are the three pieces because there are three subtypes. So the car can be yes or no, truck can be yes or no, and electric vehicle can be yes or no. So if we had a Tesla, we would have car, question mark, equals yes, because it is a car. Truck, no. At least we're not talking about the Cybertruck. Let's just say this is a Model 3. An electric vehicle, yes. A Focus, a Ford Focus, would be car, yes. Truck, no. Electric vehicle, no. And then a Cybertruck, obviously would be car, no. Truck, yes. Electric vehicle, yes. So obviously, as we saw in the disjointness constraints, the subtype discriminators are related to those disjointness constraints. When we have a disjoint rule relationship, right, we know that something can only be one of the subtypes. And in those cases, the subtype discriminator can be simple because it can only be one of the things. In more complex situations where you have overlapping rule and something can be more than one of the subtypes, you have a more complex attribute, which is a subtype discriminator attribute, vehicle type in this case, right? And there's no special notation telling you which of these is the subtype discriminator, so just be aware. Vehicle name is not the subtype discriminator. Vehicle type is the subtype discriminator, okay? And over here, vehicle type is still the subtype discriminator. In this case, obviously, it's a composite attribute as opposed to a simple one. But there's nothing that indicates it's the subtype discriminator, as far as I know. All right, but again, in the overlapping rule, you have a more complex situation, so you have to basically say for each of the subtypes, is it or is it not that subtype? So an important note, something to really be aware of. So we talked about completeness constraints, we talked about disjointness constraints, and we talked about subtype discriminators. And because we've kind of gone through many of these concepts pretty quickly, just want to be very clear. The relationship between completeness constraints, disjointness constraints, and subtype discriminators is such that completeness constraints and disjointness constraints are independent of each other, okay? The value of the completeness constraint, whether it's total specialization or partial specialization, those are the two completeness constraints, does not dictate the value of the disjointness constraints, which are the disjoint rule and overlap rule. And as you can see on the table below, you can have every combination. You can have, total specialization with disjoint rule, total specialization with overlap rule, etc. Right? Subtype discriminators, on the other hand, are dictated by the value of the disjointness constraint. If you remember, when we do subtype discriminators, it really is dictated by whether or not we have a disjoint rule, where the subtype discriminator can be a very simple attribute, just car, just truck, just jet, versus the subtype discriminator for an overlap rule, where you can have more than one subtype. So it could be car yes, jet no, electric car yes. So just to really hammer home the point, especially that completeness and disjointness constraints do not dictate each other, let's go through really quickly the different combinations. So we have total specialization, right? And this will also be a way for us to remind ourselves of what the notation is. Total specialization is the double line from the supertype to the circle. Disjoint rule is the lowercase d, okay? Total specialization means that the instance has to be essentially a subtype, has to be at least one subtype, and the disjoint rule means that it can only be one. It can't be multiple, right? So this is a total disjoint, and because it's disjoint rule, the subtype discriminator can be a simple discriminator. Vehicle type equals car, vehicle type equals truck, vehicle type equals jet, and here's the discriminator, you might remember, vehicle type. So here's total specialization again, double line for total specialization, and once again, total specialization means that the entity instance has to be essentially a subtype. That's kind of a simplified way of looking at it, but that'll suffice for us. The entity has to be sort of a subtype. And the overlap rule means that it can be more than one subtype simultaneously. So again, the idea of a Tesla where it's an electric vehicle equals yes, and it's also car equals yes. Therefore, the subtype discriminator, because it's overlap rule, has to be essentially a composite, more complex. Again, vehicle type is a subtype discriminator with a composite attribute. Now we have partial specialization, whereas total was a double line, partial is a single line, so by default it's a partial specialization, and what that means is not every entity instance actually has to be a subtype. So for instance, if you had something like a bicycle and you didn't have a subtype for it, the bicycle could just be a pure vehicle, so to speak. Okay, the bicycle could be of the supertype. So that's partial specialization. The entity instance can be the supertype, essentially. And we have a little d for disjoint rule, okay, which means it can only be one of the things. It can be a vehicle type equals car, it can be a truck, it can be a jet. Something to be aware of, it won't really come up for us, but you might be wondering if it's a partial specialization, right, and it can be of this type, what should the vehicle type attribute, subtype discriminator, what value should it have when we're using a bicycle and it's of this type and we're not using a subtype, we're not using jet, whatever, truck, car. And the answer is, it appears that the answer would be a null. So the vehicle type, subtype discriminator, the value, if you had a car, would be car. If it was a truck, it would be truck. If it was jet, it would be jet. But if it was a vehicle type that we did not have a subtype for, and we were just using the supertype, then the vehicle type would just be null. Okay, this is a partial disjoint. And then finally, just to complete the set, we have a partial overlap. Partial, single line, overlap, O, right? Overlap meaning, once again, it can be more than one thing. Partial meaning that it could still be just the supertype, right? Now with this combination, partial specialization and overlap, you could conceivably have something, for instance, like an electric bike, which would be both an electric vehicle and would also be a bicycle, so we don't see a subtype for bike. So the bike would actually be of a vehicle type. Because of partial specialization, we're allowed to code a bike as a vehicle type. It doesn't have to be a subtype. And because of overlap, it can be more than one thing. So we would have a bike as a vehicle type, and it would be, an electric vehicle as the subtype. This is probably, in terms of complexity, beyond what we'll ever need to deal with, but it's good to be aware that essentially, the real takeaway here is that disjointness and completeness don't dictate each other, okay? But subtype discriminators are dictated by which disjoint rule or overlap rule is being employed. The final topic we'll discuss are what are called supertype and subtype hierarchies, and we're actually going to discuss something called entity clusters as well. So the definition of a supertype subtype hierarchy is a hierarchical arrangement of supertypes and subtypes in which each subtype has only one supertype. And really this is kind of a simple concept. So we've dealt a lot with supertypes, like in this case maybe person, and then subtypes would be employee, alumnus, and student. But these subtypes can also be supertypes in their own right. So a person, has subtypes employee, and then the employee has subtypes faculty and staff, right? And we can see the relationship can differ between this supertype and its subtypes. This is a total overlap rule. And then here we actually have a partial disjoint rule. So how would we read this? For instance, we're saying that this supertype and these subtypes have a total specialization rule. So every person would need to be an employee, an alumnus, or a student. And when I say or, actually it's an overlap. So every person would need to be an employee and or an alumnus and or a student, right? But they can't be sort of a pure person. And if they're an employee, or if they might be an employee and an alumnus, but if part of what they are is an employee, they also have a partial disjoint rule where they can either be faculty or staff, or because it's partial, they could be a different kind of employee that's neither faculty nor staff, but they couldn't be faculty and staff. So it can get a little bit complex, but if you kind of take it slowly and you look at the rules and what they mean, you can sort of piece it together. And something to note is that in this kind of hierarchy, the subtypes inherit all of the attributes and relationships all the way up the tree to the top supertype. So a faculty member is going to have the attribute rank. It's also going to have the attributes salary and date hired, and also the attributes SSN, name, address, gender, date of birth. They inherit all of these things all the way up the chain. They don't inherit anything from the siblings, from their uncles and aunts, so to speak, but from their parents, or from their parent, and from their parent's parent, they would inherit all the attributes. And likewise, if there were relationships coming off employee or off person, they would inherit those as well. The second concept, and we're just kind of throwing this in, is actually a really simple one, and this has to do with simplifying visually what we're looking at when we're looking at ER diagrams. Here we see what's called entity clustering. An entity cluster is a set of one or more entity types and associated relationships grouped into a single abstract entity type. To this point, we've looked at some very simple examples. We'll have maybe 3 or 4 entities on the board. We'll have, a relationship or two, something that looks kind of like this. But what happens when you have 30 entities and they're all interrelated and it gets really complicated? And let's say that you're trying to present this to stakeholders who really don't need to understand the details of, if you can see here, there's a salesperson and they serve a sales territory that does business in, and they just want to know kind of at a very high level what the relationships are, what the different sort of concepts are, or in this case, what we're calling clusters. And so if we zoom in, essentially, this is the same image, but just kind of zoomed in. What we can do is kind of draw out this dotted line around related entities, and we're calling this a cluster, and we'll give it a different name. We'll give it a name, like in this case, we call it selling unit. And what we do is we call this a selling unit, and then we take note of what the relationship is that relates it to the rest of the ER model, of the ER diagram. So in this case, we have, a salesperson serves a sales territory, has a one-to-many relationship to does business in. But we reduce that, and again, this is just for visual purposes. We're not actually changing the entities underlying anything. This is just so that we can present it differently. We call this entire thing a selling unit, and we maintain the same relationship. So over here you can see we have a selling unit now, and it maintains the same relationship to does business in. So again, this is just a way for us to represent these things more simply. Now, if you had someone, a stakeholder or whomever, you presented this and started at this high level, and they wanted more detail, then of course you would break it back out into the more detailed set of entities. So the entity cluster really is just, I think, a way for us to simply represent complex ER diagrams. And on that note, that will be the end of this video, and I think that will be the end of the videos for Chapter 3 as well. So I will see you in class.